Sometimes you get confused even from the very simplest questions. And today we're going to discuss those. Let's start with the most shortest question, which is I to the power of negative 1 is equal to what? Now, it just, very, one word question, but then men just don't know how to solve it. What you have to do is just, take the reciprocal so that the exponent can be positive, and this applies to all questions, even the ones which does not involve complex number. You always have to convert the negative exponents into the positive just by taking the reciprocal. So, for example, if you have 2 to the power of negative 1, just take the reciprocal and, ooh, the exponent is now positive. Similarly, if you had 1 over 2 to the negative 3, again, reciprocal, and the exponent is now positive. I'm applying the same logic here. It's 1 over I. But oh, there's another problem. We cannot have I in the denominator. We discussed it the last lecture as well. So what do we do? Multiply and divide by complex conjugate. Hence, it equals to negative I because we change the complex part. The complex part was 1 because it's 1I. So we change it to negative 1, which is negative I. Hence, the case equals to, and as you already know, the I square is negative 1, and the answer is negative I. So, very simple. I to the negative 1 is just negative I. In a similar way, you can solve other powers, negative 2, negative 3, and so on and so forth. We also have some questions which look, you know, like lengthy, like if they can take more time, but they are not. For example, now apparently it may look like, oh, there are a lot of exponents. How will I solve it? But again, the same rule, the same plate, divide them with 4 and get the remainder. I know in the case of I to the 59, the remainder would be 3 because I know the 4 times 10 is 40 and then 4 times 4 is 16. So 40 plus 16 is 56. So the remainder is 3. That means I can replace it with I cube. And if you do remember the sequence from early on, it was I, negative 1, negative I, and then plus 1. The third one is negative I, so negative I here. Or you may do it step by step. So like I3 first. Similarly for 68, I know the 60 is in the fourth table, and then 64 and 64 remainder is 0 here. That means you have to choose the last one, I to the power of 4. And similarly in the last question, the remainder is 1. So that's why the first one, I as it. If you solve it further, you will get negative I times I to the power of 4 is 1. And similarly, the I as it is. So after the cancellation, the answer comes out to be negative 1. Let's discuss another question in which you have a numerator and the denominator. We already did a question similar to that, which is multiply and divide by complex conjugate, and you get the desired answer. Now we have a square in the numerator and a square minus b square in the denominator. I hope you remember that formula. Now, in this case, you also need the a plus b whole square formula, which is this, and hence substituting I square equals to -1 will give us this answer. Now, in this case, if they ask you, like, what is the real part of this answer, then you must find the real part. In this case, you can separate the denominator, hence the real part would be -5/30. Similarly, the imaginary part would be 6/30. Now, how do you add or subtract complex numbers? It's again very simple. Suppose you have these two complex numbers. By adding them, you are adding the real parts as well as the complex parts, and that's it. So real parts 2 plus 3, and the imaginary parts 4 minus 3, which is 1. And the same happens for the subtraction. So if you subtract them, it would be A minus C and B minus D. And this plus sign will remain as it is. Thanks. If there are brackets here, so 2 minus 3 minus 1, minus 3 minus 4 is -7 up.